Hi, I'm Bob. Welcome back to 5 Minute Econometrics. A data problem we often deal with is the sample with missing data, or the non-random sample. Data could be missing for various reasons. The missingness could depend on the explanatory variable in the model, or it could be related to the outcome variable. Recall that one of the Gauss-Markov assumptions is the random sampling assumption, meaning that we have a random sample of n observations. If the random sampling assumption is violated, the OLS estimator could be biased and inconsistent. When the data missingness depends on an explanatory variable in the model, we can still obtain an unbiased and consistent OLS estimate, since we have already controlled for that explanatory variable in the model. However, if the data is missing because of the outcome variable, then the non-random sample may not represent the entire population of interest, and the OLS estimate could be biased and inconsistent. The former is an example of the exogenous sample selection, while the latter is an example of the endogenous sample selection. We will have a look at the difference between the exogenous and the endogenous sample selection today. Exogenous sample selection occurs when the missing data is based on the explanatory variables. It will not bias the OLS estimates for the population parameters. For example, the population model relates a person's annual savings to her income, age, family size, and some unobserved factors, mu. We want to estimate the saving behavior for all adults. Suppose the data came from a survey of people over 35 years of age. It is a non-random sample of all adults, but we can still obtain unbiased and consistent estimates of the parameters in the population model. The reason is that the factor on which the sample is selected is age, and age has been controlled for in the model. It makes the OLS estimate from the selected sample representative of the entire population of interest. By contrast, endogenous sample selection occurs when the missing data are based on the outcome variable. If the sample is based on whether the outcome variable is above or below a certain value, OLS is likely to produce biased and inconsistent estimates of the population parameters. Here is the same population model. We want to understand the savings behavior of the population of all adults. However, this time we only have data for people with savings below $50,000. This is a non-random sample from the population of interest, and it is selected based on the value of the outcome variable. The OLS estimates will be biased and inconsistent because the sample cannot represent the entire population of interest. The saving behavior probably differs between people with and without $50,000 in savings. That is, the relationship between savings and the income and age could be different between these two groups of people. The major difference between exogenous and endogenous sample selection is whether the factor behind the selection has been included as a control variable in the model. In the first example, data are missing because of age, and age is a control variable included in the model, so the OLS estimates are unbiased. By contrast, in the second example, data are missing because of an individual's savings. Savings is the outcome variable that relates to the explanatory variables in the model and the unobserved factors in the error term. In other words, some of the factors behind the sample selection have not been accounted for in the model, and they are included in the error term. If these factors are correlated with the explanatory variables, then the zero conditional mean assumption is violated and the OLS estimators will be biased and inconsistent. Endogenous sample selection can be viewed as a special case of omitted variable bias because the factor that leads to the selected sample is omitted from the model. The bias caused by an endogenous selected sample is usually called the sample selection bias. Here is a well-known example of endogenous sample selection. Estimating the return to education for married women. The model relates married women's hourly wages to their education, work experience, age, and other demographic characteristics. The sample consists of married women who earn positive earnings, with the outcome variable being the logarithm of their hourly wages. Married women who stay home to take care of their families are excluded from the analysis. To estimate the return to education for all married women, we must consider whether our sample represents the entire population of interest. The return to education may differ systematically between women in the labor force and those out of the labor force. In this example, the sample selection is based on the married women's willingness to participate in the labor market. The women's decision to work or self-selection into the labor force could be affected by unobserved factors, and these unobserved factors are omitted from the model. Without considering it, the OLS estimate of the return to education may be inconsistent for the entire population of the women of interest. Today, we discussed the difference between the exogenous and the endogenous sample selection. Missing data results in nonrandom sample, but not all nonrandom samples lead to biased and inconsistent OLS estimates for the population model. If the data missingness is based on the explanatory variables we have already controlled for in the model, then it is the exogenous sample selection, and the OLS estimates will be unbiased and consistent. However, if the data is missing because of the outcome variable, then it is the endogenous sample selection, and the OLS estimates will be subject to sample selection bias. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.